We are here to talk about AI ethics and natural language processing. I'm also an AI advisor at Evenness. I'm a DeepMind Scholar. My background is, well, at first very technical. So I started out with AI and robotics, went into NLP then, and I'm now working at the Ada Lovelace Institute on the impact AI has on society. So it's very AI ethics focused. My mission really is to build AI that works for everyone, because as you probably know or noticed, at the moment we're just building AI for a very small group of people, and we're ignoring a huge part of the world, and I think we can do better. That's why workshops like this are just so important, to share knowledge and have these discussions about AI ethics as well, and just get everyone on the same track and include different people from everywhere. Let's go into the background. Why are we really doing this? As you can see, AI is everywhere, and it has a massive impact on everyone. And we sometimes assume that it's maybe just us, but even when I talk to my grandparents, they know what AI is, and they're in their 80s. I talk to my family in Ethiopia and East Africa, and they're telling me about technologies that they already built, and I'm just amazed by that. And then I come back here and I realize, okay, we are not having the same discussions together. So I think it's very important to share different perspectives to really include everyone in this world. You probably remember when, for example, ChatGPT was first introduced. It was such a shock to everyone. No one saw it coming. And then suddenly you had all these people who, well, called themselves AI experts. I don't really think we can call ourselves AI experts, because there's just so much to know, and like impossible to know everything, and we still don't have all definitions. But even those people had no clue what ChatGPT was actually capable of and how it worked, what data was used to train it, how it was tested. We had nothing, and we still don't really have a lot, because OpenAI just refuses to be transparent. But yeah, then I really thought about the impact this will have, because suddenly everyone is told that they can use this ChatGPT in their everyday lives without any prior experience in AI. So people just use it as a search engine. And the problem is really that no one told them about the risks, the limitations, what they have to look out for. And imagine you live in a place where maybe medical treatment is not as accessible as maybe in Europe. And then you ask ChatGPT, and how do you know what ChatGPT tells you is actually true or not? So yeah, there are lots of ethical questions to be considered when it comes to AI, and especially large language models. That's why I'm including NLP and AI ethics here. Let's get into the overview. As I already said, this will be a two-part workshop. The first part will be this presentation about AI ethics and then natural language processing. What is it? What are different techniques, methods? How can you apply this to your everyday life? And then part two will be on Google Colab. You'll be able to interact with it as well. Depending on your experience, just let me know how far you get. And we'll go through some practical examples to see, okay, how can we analyze data sets? How can we build our own networks? How can we analyze whether there's bias or not? This is the general overview, and I can already see there are more people coming in. So AI ethics, what exactly is it? As you can probably already tell, it's really just about ethical considerations and principles that are concerned about the deployment and development of AI, because we have so many new technologies coming out every single day. There's always a new update, always a new thing that we can use with AI. The only problem is we don't really have the rules and the regulations set out yet, because we can't keep up. We don't really have enough people that will be able to create these rules and regulations. And even if we have those people, usually they all have very similar backgrounds and come from a very similar place. And I think we really have to mix that up and bring other people in there as well, and really have a new standard of talking about regulations when it comes to AI. One example is bias, AI bias, algorithmic bias. There are different names, bias is everywhere. It's how we grow up. It's how we go through society. Some people might argue it's what keeps us alive, but I think it can become very toxic and very excluding to some yeah, minorities, marginalized groups.
My heart smiles as I bask in their legacies, knowing their lives have altered many destinies. In her eyes, I see my mother's poise. In her face, I glimpse my auntie's grace. In this case of deja vu, a 19th century question comes into view. In a time when Sojourner Truth asked, "Ain't I a woman?" Today, we pose this question to new powers, making bets on artificial intelligence, hope towers. The Amazonians peek through windows blocking deep blues as spaces increment scars. Old burns, new urns, collecting data chronicling our past, often forgetting to deal with gender, race, and class. Again, I ask, ain't I a woman? Face by face, the answers seem uncertain. Young and old, proud icons are dismissed. Can machines ever see my queens as I view them? Can machines ever see our grandmothers as we knew them? Ida B. Wells, data science pioneer, hanging facts, stacking stats on the lynching of humanity, teaching truths hidden in data, each entry and omission, a person worthy of respect. Shirley Chisholm, unbought and unbossed, the first Black Congresswoman, but not the first to be misunderstood by machines well-versed in data-driven mistakes. Michelle Obama, unabashed and unafraid to wear her crown of history, yet her crown seems a mystery to systems unsure of her hair. A wig, a bouffant, a toupee, maybe not. Are there no words for our braids and our locks? Does relaxed hair and sunny skin make Oprah the first lady? Even for her face well known, some algorithms fault her, echoing sentiments that strong women are men. We laugh, celebrating the successes of our sisters with serena smiles. No label is worthy of our beauty.
And depending on who builds our AI systems, who gets to make all the decisions that will, have a huge impact on our life, it gets really dangerous when we don't really look at the data sets. So in this case, before you build an AI system, make sure that your data set is not affected by any, for example, racial bias, gender bias. There are so many different ways a data set can lack inclusivity and diversity, and that's very important that we keep track on what data we're using. Then also privacy. How do we get this data? Do the people whose data we're using know that we're using their data? Do they actually approve? And this is something that every country does differently.
The trolley problem is a question in ethics that's become acutely relevant for people working on artificial intelligence. Suppose there's a train hurtling down the track and it sees 5 people standing on the track in front of it. Now it can't stop, so if it does nothing, it's going to kill them. But on the next track, there's only 1 person standing, and so it could choose to switch to the next track. That's an ethical dilemma for a train driver, but in an artificial intelligence system, an autonomous train or an autonomous car, that's a dilemma for the designer of the artificial intelligence itself. And so we have to start thinking about machine design ethically from the very beginning, and you will hear a lot of dilemmas like this being brought up in real life by people working right now on the machines that are set to transform the world around us.
A different answer. And there was one example where it actually asked about a sentient AI. So what if the train would actually destroy the only copy of a sentient AI? Would it then, change the lane so that 5 people die, but the sentient AI would survive? And it said yes. So, but yeah, it's very interesting. There's a huge rabbit hole out there on the internet with people discussing this trolley problem. In general, we can say that we probably all used ChatGPT or even Google Bard by now, and there's a main problem with these large language models in general, because we don't have any information on the training data, the test data, the different processes. How do we know that it was actually trained and tested with people like us, people who are not like us? How long was that testing period as well? So always when you use these kinds of LLMs, please just assume that there is a bias automatically, because obviously they're usually trained with data that we humans created on the internet over the past few years. And as you know, the internet is not always a very nice place for everyone. All the racism, sexism, homophobia, everything is in there. All these systems are trained with that as well. Every time you use these LLMs, just beware that there's most likely going to be some kind of bias. And even if you ask for answers, there are going to be errors, of course. I mean, even we humans make errors. So how can we expect a large language model that is trained with our data to not make any mistakes? So always beware when you get these answers and double check again. Also, when you think about it, these large language models, they were created so we can use them in a general sense. But some people think that also means like health related questions, or when they want to try out something in maths and they realize, oh well, it's a language model, not a very mathematical representation. So just make sure that even if you use it for health tips, that you please double check. But yeah, I hope you are aware of that. But as you can see in the image right here, that's just a screenshot because there's a new update on Google Bard that I think ChatGPT is really missing out. And it's that you can double check the information that Google Bard can give you. I just asked a very simple question: who's the current reigning monarch in the UK? And for example, ChatGPT doesn't really know that, because all the data that was used was until 2021, was when the Queen still lived. So everything new that happened after 2021 is not really inside the data set unless they retrain it and like really update it. So I was curious to see whether Google Bard knew it, and the information I got was right. And you can even see when you click on the Google icon there where it comes from, what the source is, and you can even click on the source and read it yourself then. And it even gives you search questions for related topics. And I think this is a real game changer because now you're in control of the data that you get, and you're more likely to double check now that you get the option to do it. If you have to choose between ChatGPT and Google Bard, right now I would tend toward Google Bard, but obviously that's your preference, and just make sure that you really double check. But the question is, how can we double check? So as I just mentioned, the Google Bard function is really good. But also, if you just search for it yourself, I mean, obviously, we use these large language models because we want our life to be easier, to just, be simpler and quicker. But if we just have a short Google search somewhere about the info that we got through the LLMs, that's already going to make a huge difference, because sometimes you see that it might just be the name of a person that is wrong, or the year of something, but this can have a huge impact when you use that in very important documents. But also, the good thing would be if one day we had like large language models where we can ask for explanations. Why did they write it that way? Why did they give us this information? And because we could ask ChatGPT that right now for these explanations. The only problem is, how do we know that's the actual explanation? How do we know it's not just a new generated text predicting what the most likely answer to this question should be? So one way would be also to just test the LLM with different inputs. Maybe rephrase the sentence, rephrase the prompt. Also compare different generated answers to the same prompt. So sometimes, you can switch between the different answers on ChatGPT, and Google Bard gives you different drafts. So I think it's very interesting sometimes to see the differences. And when they're like big differences, then you really have to wonder, okay, how do I know which one is the correct answer now? But also, there are other people who are experts on certain fields, and if you can, just reach out and ask them if you're not fully sure. But yeah, please never just trust the large language model. It's very important to understand the reasoning behind these systems, so we can see whether there is bias, whether there is anything that we have to change, maybe, include a few more people, which is always good, I think. There's a general term for this called explainable AI, short XAI. Basically, it's the ability of an AI system to explain why it did it, and the decisions behind the different processes, and to explain it in a way that humans can understand it easily. And we do this to identify and mitigate bias and errors as well. I don't think we're at a stage yet where we can fully trust the answers that we get. We don't know if it's just another generated thing or if it's the actual answer. There's a car company that's called Wave. They create autonomous driving cars, and they just added a new feature that after a test drive, they can ask the software whether why it did certain things. So for example, you can ask, oh, did you see that person crossing the road? Is that why you slowed down? Why did you turn right here? Why did you not stop when someone wanted to cross the road, and so on. It's a very good feature, but even there, you don't really, you can only get like the very factual data. But when you really want to get the real decision making information, then it's hard to really get the correct answer or to know whether it's correct or not. Explainable AI is very important to just understand ethical and responsible decisions, because we really need that information in order to ensure that it's safe to use in a very general use and in our society. If you ever were to create your own systems, make sure that it's explainable, and that even people who don't know anything about AI are able to understand how it works and what they have to look out for. We can also briefly talk about algorithmic bias, because I think that's a very important topic. And there are different projects that were conducted, different research as well. For example, Dr. Joy Buolamwini worked on the Gender Shades project at MIT and found out that the facial recognition software, not only was more likely to misidentify women and people of color than white men, but also there was a huge misclassification error when it came to that. 34% accuracy, and that is basically that's huge. And if you think about, airports or CCTV in general in public, if every third woman of color is classified, then that's really not safe for them. But also, there's another study by ProPublica that analyzed the different AI hiring tools, for example, used by Amazon. And of course, here again, you have gender bias where men were more likely to get the job, and that was usually because of the historic data that the AI was trained on. Because in the past, there were more men in these job positions, so now the AI was more likely to give the new job to, again, a man. And another study also showed that some, well, at least in the US, in the criminal justice system, they used AI to see whether someone is more likely to commit a crime again, or be arrested or not, or should get even worse penalties than it was supposed to get. And there was a heavy racial bias in there. So yeah, these are issues that have a huge impact on the people that can really suffer from them. So I mean, we already have marginalized groups in our society, and then that's portrayed in the AI that we're using in our everyday lives that can make decisions that really change lives. I mean, if you get arrested just because of the skin color that you have, that you were born with, then we really need to change something about this system. So we need more people from different backgrounds who can weigh in on these decisions and make sure that the data that we use, for example, to train these AI systems is not biased, that the people who built it are a very diverse group of people, so that we get as many perspectives as possible into this. I don't know if it's actually possible to have completely unbiased data. I think this is very hard to achieve because just in general in society, we're always biased. And what would it mean to have a completely unbiased data set? We need, for example, in a facial recognition application, we need an image of at least a few people from literally every country. But then, we have people of mixed race, we have people with disabilities, we have people that just look different, have different facial features. So we really have to include everything in order to remove the bias aspect. We also have to find a definition for fairness, because I think it's different everywhere and it has a different weight everywhere as well. I think just test everything that you build. So even if you build your own systems, even if you build your own neural networks, just make sure that you tested with data that the network does not know yet, so you can see whether it actually works or not. Maybe add some noise to your data set. So for example, if you work on a neural network that is supposed to classify different traffic signs in a city, make sure that you add some traffic signs that have stickers on them. There's not a single traffic sign in real life that is clean. Just make sure that you test everything and that you really think about the worst case scenario as well. Don't be like OpenAI and hide all the information. Be transparent and really talk about what you used, what data did you use, what was your process behind it, and why did you make certain decisions, and why did you think about it? Like how did you think about certain issues as well? We definitely have to increase the representation of women and people of color in the development process. I think this is really one of the reasons why I got into AI, and like I'm so stubborn to stay in there as well, because I realized when I first started out that I got into a room and it was literally 20 other white guys, and then it was me. And okay, maybe, well, you don't really know my face at the moment, but I'm mixed race. So my mother's from Ethiopia, my father's from Germany, and I just realized that there are no other people that looked like me back then that did that, at least where I grew up. And then when I came to the UK, I realized, okay, there are more people, which is good, but in my opinion, it's definitely not enough. So when I studied, we were, I think, 20% women, and the rest was men, obviously. Then you had um, maybe I would say 40% were not white, which was good, but I think this is also very special in London. Depending on where you study, it will definitely look different. But I think this is such an important thing that you mentioned, because really this is what's going to change how we build AI. But yeah, that was the first part. And we're now going to talk a bit more about natural language processing. Natural language processing in general is just how we interact with like computers and human language. In this case, natural language is human language. And we're really thinking about how can we make systems, AI, computers understand and decipher our human language so that we can create new text and speech. And I think it's very important to think about whether we can actually use the word understand, because I don't think AI really understands what we're saying if it's in text format. It just uses that information to, go through the processes and generate maybe new text. As you already know, then that now, since we're talking more about these things, about machine learning and AI in general, and more people in the public are part of these conversations. So it's not just people that come from a technical background. We realize that there's so much we haven't talked about yet. So that's why, for example, the connection between AI ethics and NLP is so important, because you always have very technical people that only work on general things in AI or machine learning, but they don't really think about the impact this will have on society. And then you have people from humanities and society that don't really have the in-depth knowledge of machine learning to really see, okay, what impact can it actually have? So I think we really need the bridge between these two parties, to have these valuable conversations and that we can actually make a change. With natural language processing, for example, right now we're using text, and text obviously has a very different structure compared to art, where art is usually, when it's digitized, then it is given to a neural network as pixels. So for example, if you have an image with colors, then you have RGB, and each pixel has a different value for each. So for example, R would be 10, G would be 20, and B would be 30. I don't know what color that would make, but that is the input that you have. So in a way, I think language is a bit more complex, but the same issues appear in generative art, of course. I mean, there's still bias. If you want to create certain images that maybe show, okay, a person working at an office, then if it's a CEO, it's most likely a white man, and if it's the cleaner, it's most likely not a white man. In generative art, there's a whole new discussion when it comes to AI ethics, because I think that's where we can really see the bias as well, because it is portrayed in the art. In general, NLP, as we already talked about, is very text focused, and we have 5 examples here. So we can use it in machine translation, which would be Google Translate, for example. Then we have text summarization. That is now a field where you can summarize books, articles for yourself, if you're, for example, too lazy to read them. There are even people working on multi-modal solutions. So for example, where you can watch a video and it will be summarized in a text format. So then you have, 2 models that work together. First, you need something that can interpret the video, and then you need something that can take the text from the video or the context of the video and summarize that. Then we also have question answering, so chatbot, then sentiment analysis. If you think about, tweets, articles, what is the general sentiment of that text? Is the person writing this happy? Is the person sad? Is it intended to be an insult? This sentiment analysis part is very important in social media in general, to see, okay, if there's hate speech, if there are fake news, if people are targeted. So that is a very big topic in NLP. Then, of course, we have text generation. So ChatGPT, Bard, and everything like this. Before we think about how we can build our own natural language processing or language models in general, we need to think about how we represent the text. Because as I already mentioned beforehand, when it comes to generative art, or in general computer vision, you have images, and these images have pixels, and they are basically fed into the neural network. And each pixel has their own vector, and then that vector is used to train the neural network and test it, and so on. Whenever you have anything with images, anything digitally, then you always have the pixels that are fed into the network. The only problem is text doesn't have pixels, and there is no way we could really put this into a pixel format. And even if we had it as a pixel format, then it would still go back into computer vision, for example, with the handwriting. So we need a different representation for text, for language. And that representation is very complex. I mean, there are different strategies to do that. One example here is the bag of words model. This is a very, very simplified example, so everyone can understand this. Let's just imagine we have two documents. The first one says this is a dog. The second one says this is a cat. Then we basically count every single word there is within these two corpus. And then we have this is a dog and the word cat as well. And yeah, when you see all these words, of course, if there's any duplicates, that's not included, because we just want to have a vocabulary of all the unique words that appear in our general text. And if we want to see, okay, this text has its own representation, then we just look, okay, which word is mentioned here, and then document 1 has 1 and 0 at the back, because cat is not in the document. And document 2 is the other way around, because dog is not in the document. So that's very simplified. In reality, the first step would be to pre-process the text. So that means we clean our text that we want to use during the training process. So that means if you have a text, a normal article, usually the words that we use, you have, for example, is, a, the. These are words that appear very often, but they don't really have any importance when it comes to understanding the context. So we strip the text of all these unnecessary words. Then we clean up the words to put them into a singular form. So if there's dogs, then we put them back to dog. If it's I slept, then you put it back to sleep. And I is also removed. So in the end, if we did this to the two documents that we have in this example here, we would only have dog and cat, because these three words are not really relevant to train a neural network. So this is a very important step to consider when you train your own language models, because it will still be able to create new text and understand an entire sentence, but we need to put more weight on the actual words that hold some information and some importance. So that's why we focus more on the actual words. And then we have large language models. Basically, what is the difference? Because I just talked about the bag of words model, but as you can imagine, large language models, they don't have the name for nothing. They're just language models that are trained on huge amounts of data. And this is so we can assure that it can be used on literally anything and for everyone. The more data we use, the higher the accuracy of the generated text is, which is what we want to have. The only problem with that is if we want to use, for example, the bag of words model, then if we have huge amounts of data, obviously the representation that we have right here would become too complex. And in order to train the model, that would take probably years to finish. And we don't have that. So we need a different representation, because we have too much data, the model would be too complex, and there is literally no context between the words. So here, dog and cat, they don't have any connection between them. That's why we have transformers. I don't know if you've heard of that before. And no, it's not about the movie by Michael Bay. It's a completely different context here. Transformers were first introduced in the paper Attention is All You Need in 2017. And since then, natural language processing has been turned upside down because suddenly everything became just so much easier and so much more efficient. So this has been used in basically anything in NLP, and even ChatGPT and Google Bard are most likely trained with transformers because that would just make sense. And the difference here is really, what do? They use self-attention, which is a method that they introduced in that paper, which means they put a different weight on each word depending on the context. So when I read an article about, for example, the American presidency, then I know that Trump will most likely appear there, maybe Obama, maybe Biden, and like different people. So I want to know that if I ever see the word Biden, that I know that this is connected to something political. It's probably not going to be about his music taste, or, well, we never know. But yeah, the chances of him being mentioned in a very political article are higher than maybe something in entertainment or science. That's why we need context. As you can also see down here, there's a small example. So we want to have a language model that can really understand the relationships between the different words and phrases. Because if we have this, Sammy said she likes dogs. Do you like them too? Then we need to know that the she refers to Sammy, which is in itself already not really inclusive because we just assume that Sammy is female, and that is in general I think a very big issue in natural language processing because we don't have enough data that really introduces non-binary people as well. But let's just assume, okay, someone wrote, Sammy said she likes dogs. Do you like them too? Then we also need to know that the them in this question refers to the dogs and not, for example, Sammy. So this is something that would be really hard to do with a model that just uses the bag of words model and the very simple representation. And that's why we need transformers, so that we have the different weights as well, so that we know that if we have a text that says Sammy said she likes dogs, that the she and Sammy are somehow connected when they are fed into the neural network, and also the them and the dogs. But yeah, this is one of the main differences between like transformers and very simple language models. And this made all the difference back in 2017, because suddenly you had language models that could really comprehend what you were talking about. Even when you write a text that challenges even us humans on the context, if you're going through a room and you're mentioning 20 different items, how do you know which item is where in the room, and what is the context between the items? How does the algorithm know that a teapot is used to make tea with and the cup is used to drink from? So this is something that was really changed once the transformers were introduced. I hope that was not too technical. I did not include anything, any vectors or any architectures for any neural networks, because I think that would have been too much. If you want this, I can still send it through later on. But yeah, so far, this is the natural language processing part of the presentation. And I just want to give you some tips in case you want to do something yourself. I'm aware that there are always people that come from a different background, maybe studied something in humanities and are now interested in AI, but it's sometimes so overwhelming when you see all these people talk about it. And obviously what they sometimes talk about is just science fiction related topics about AI, which is obviously not the right representation for AI. I think if you want to start out in AI, or just in general, natural language processing, even code yourself, the first thing I would do is set up a GitHub account for yourself. GitHub is a website where you can have access to literally any type of coding. It's a very good directory for also documenting your own coding journey. You can upload everything, you can have it all in one place, and you can share it with other people. For example, you might find some tutorials that uploaded their code to GitHub, then you can use this code to build your own stuff. I think it's just a very useful thing to have. And to have your code all in one place. I really recommend that if you want to work on your own project, before you do that, please go through some tutorials that are very similar to your project, so you can understand what you're getting into. And there are so many tutorials out there. There are so many YouTube videos, so many platforms where people explain how to code certain things, so many articles, so many people making this open source and accessible to everyone. So just use that, learn it yourself, because you can do that. Everyone can. It's not as complicated as it sometimes sounds. If you find anything open source, just make sure that you still refer to the author and join any communities with like-minded people, because I think that's what really helped me get through all of this. And even in this space, talking to you guys, that's already something, and it's just very helpful to be in a space where people want to achieve the same things as you. And all you need to do is really just start. And if you want to start, I have some resources that I put here. Obviously, you can't click on the links right now, but it's, I think, very recommended to check these websites out. For example, the AI ethics principles from Google AI. I'm not saying they're perfect, but they're, I think, good enough to just grasp how a company is dealing with AI ethics and how can we improve that. Then there are different institutes, for example, the AI Now Institute. Then we have Partnership on AI. They all work on making AI more accessible, more responsible as well, and also think about the ethical aspects. Then we have the Stanford Human-Centered AI Institute. They always have some courses. The Allen Institute for AI, and the Gender Shades project that I also mentioned by Dr. Joy Bulambini. I think she's even publishing a book soon, this month, I think, about her journey and her project, and it's definitely worth it to check that out. There's also a TED talk by her, and it's really powerful when you hear about her story and how she basically had to realize, so she's an African American, when she built her own facial recognition application, that it did not recognize her face unless she put on a white mask. And just realizing this fact, I think, is just, I cannot even imagine her reaction. It's really important to think about different aspects within AI and also AI ethics, and include different perspectives. And if you want to go deeper into coding, there are some really helpful websites. For example, Hugging Face. They let you access large language models for free. It's all open source. So someone else built a large language model, and you can use that to train and test your own models and build your own stuff. Then there's Kaggle. They offer lots of data sets that can be used for the training purposes. Then W3 Schools is just amazing when it comes to literally any programming language that there is. And as I already mentioned, GitHub is here. So I prepared two separate documents because I just wanted to go a bit into, first of all, data analysis. So we can look at how can we actually find out whether a data set is biased or not. And then I'll go through, for example, sentiment analysis here with the neural network. So for anyone who has never coded before, don't worry, I'll explain everything. So the first thing you can see is I'm using Python as a language. I'm also using a specific data